surplus at the indicated unit price. And the graph of this, if you needed it, the graph of this looks something like this. And then at P, so this is P and this is Q. At 2, it creates a little triangular wedge, and it's this area up here.
Okay.
So you have to figure out the quantity, I believe. So to get the quantity, you put 2 in for P. Is this right? This doesn't seem right. Sorry, I always use calculators for these, so I almost never explain them by hand. Trying to find my resource. Okay, found my resource. Yeah, I gave you the wrong thing here. I can't believe that. Area between the curve. We're doing consumer surplus. Okay. All right. I guess this is right. So you might have seen some formulas in class. It's the integral from 0 to P bar,
Mm-hmm.
which I don't think is right. No, I'm sorry. 0 to wherever the intersection point is, which I guess we'll call that Q. And then you take the P bar and you subtract your function. No, this is the demand function. No, sorry, it's the other way. So we're going to subtract P bar from this. Okay, I'm not doing a very good job here. So the short of this is you're integrating from 0 to some number, which we're going to find, 18 minus 2q, because that's this function, this line going down here, minus 2, because that's this number here, dq. To find this intersection point, you put 2 in for p. You set 2 equal to 18 minus 2q, and you solve and you find that q is 8. So you're integrating from 0 to 8. Sorry, that went way too far here. So you're integrating from 0 to 8. This is really 16 minus 2q now. So that's 16q minus q squared evaluated from 0 to 8. So that's 16 times 8 minus 8 squared. So do you have a number for that? I'm going to get my calculator right now too. Why did it do that again?
64.
64, yeah. Okay, so that's completely correct. And let's move to the next one. The shape of the curve really doesn't matter, but almost all of these are something that's sort of going like down and to the right. And this P is really a Y value, so it hits it somewhere. And we're just finding this area right here. We still have to find this Q. So this Q comes from finding the intersection of 5 equals 9 minus 2 Q to the 1/3. And I almost always just graph these to get that answer. And finding the intersection. So let me do that on another screen here. If you need me to, I can snip it over. But the intersection point ends up being at 8. Q equals 8. So that's this point right here. So to find the consumer surplus, which is the area above this, if you've taken an econ class, you might have seen this already too. You're integrating from 0 to 8, 9 minus 2q to the 1/3 power minus 5 dq. So you always subtract that p bar, whatever that p bar is. So if you have a calculator, you can definitely
Hmm.
um, you can definitely try this as well. This one's just around to the nearest cent. Um, I guess you need to. So you're getting 4 minus 2q to the 1/3. So it's 4q minus, let's see, q to the 4/3, 3/4. That. And you evaluate that from 0 to 8.
I got 8. I don't know if that's right.
You got exactly 8.
Yeah. Oh wait, but I think I plugged in the wrong thing.
I'm gonna use this other calculator for integrating integral. Yeah, so it is 8. You had it right. This whole thing we do eventually get to producer surplus. Okay. All right. Number 3. All right, snipping in number 3 now. Calculate the consumer surplus at the indicated unit price. So again, you really don't have to do well. This one's bad. Okay, why did they do this? So they I remember this. They have this in the wrong uh, order here. Um, in the previous problems, it was solved for p. Here it's solved for q. So you need to solve for p.
Okay.
Okay, so that's whatever. It's 50 minus q over 3. That's what p equals.
Okay.
So that's your function. So you're going to integrate that function from 0 to something, 50 minus q over 3 minus 6. And then to figure out what this upper bound is, you come over here and you set 6 equal to 50 minus q over 3. And you end up getting 32, it looks like.
Yeah.
So go ahead and throw that into your calculator and see what you get there. So I get 512 divided by 3. Does it ask you to round?
Got 170.
Yeah, so you got the rounded answer there, which is correct too, 170.67. Okay. All right. So 4, do 4 next. Okay, so this one's different. It's now asking for the producer surplus, and you still have the same issue here. You have to solve this for p. So when you solve this for p, you get let's see, it'd be Q plus 50 over 2 is equal to P. P bar equals 60. So this time the graph of this thing, it's going up and you're hitting it with this P bar and you're finding this area below. If you've taken any down econ class, they almost always give you problems where you have to find the consumer surplus and then the
Yeah,
producer
again, that's
surplus.
what.
It's
Yeah.
exactly what we're doing here. Um, so it's a slightly different formula because you're finding the area underneath. So it ends up being the integral of this P bar 60 minus the function. So it's Q plus 50 over 2. It's 0 to whatever the intersection point is.
I
That's
think
why
it's
we had to,
70.
sorry,
I think it's 70, the intersection.
it is 70. I agree. And then you just integrate that. This is a 2 down here.
I don't know if I got the right number.
What did you get?
Like a really small number.
Hmm. Should be like, I don't know, in the hundreds, I would think. Maybe not.
Oh yeah. And then now I just got 1,225.
Yeah, that's right. There's a ton of calculators that do these, but they all work slightly differently. So if you aren't comfortable with like, use if you like, you would want to use one for the homework and then use it on the test, or if you have the ability to do that. So we're up to 5. We're gonna move to 7 first because 7's another producer surplus problem. So it'd be good to do that next. I don't know why they didn't sequence it in a little bit differently, but that's what they chose to do. So here, the function is already solved for P. So again, like it's this 80 plus Q looks something like this. It hits at P bar. We're finding this area here. It's the integral from of P bar minus the P. So this is P bar minus P from 0 to wherever they intersect, which looks like it's
155.
155. See if you can come up with the answer for that one.
Okay. 12,012.5.
12,012.50.
5. Yeah.
Okay. How confident are you in that?
Mm,
I have no idea if it's right or not. I'm going to try it out. I was looking ahead to number 5 and 6. That was correct. Great. So 5 and 6 are these income stream ones. They're kind of like annuities. I've actually never seen these used in because almost everyone uses financial calculators. They never use calculus for these. So there's two things that they're asking for here. The first is the total value, and the total value is I think much more straightforward. It's always the integral r of t from a to b dt. So in your case, it's the integral of 21,000 from 0 to 18. So it's gonna be a lot. I mean, it's $21,000 times 18 years ish. I think, or eight. Yeah, yeah, 18 years.
so 37 378,000.
I think I missed a seven. Did you say
One
three?
more zero. One more zero.
Okay, so 378,000 sounds pretty correct. So let me try part A. The future value is what you get. The second one here, that was correct by the way. The future value is what you get as a result of investing this money. And it's saying you're going to get it at 4%. So this is a formula. It's let me write it down here. It's the integral from A to B again, and then it's R of t e to the r b minus t dt. So you may have seen this in class. I don't know. You said maybe I haven't covered this yet. So it's the integral from 0 to 18, 21,000. The interest rate is 4%, 0.04, and then it's 18 minus t dt. And that's definitely one you're going to want to put into a calculator. I will be doing the same here. It didn't give me any decimal places. Oh no. The calculator I'm using didn't give me enough decimal places.
I got 553,577.4356.
Okay, so about 4.4. So that's kind of an interesting number because it's way more than the previous one. Previous one was, if I scroll up here, was 378,000. That's the effect of the compound interest over each year.
Mm-hmm.
Round your answer near cent. Okay, I'm submitting that. Yay, I like that. So the next one is the same thing, but um, it's a different equation for R and a different interest rate and stuff. The They probably won't talk to you about this much in class, but like this one is a much more realistic example in some ways. Like this one suggests you're going to add more money to it each year, which is pretty true of investing. You don't just stay at a fixed amount each year; you typically add to it. So the total value here is the integral from 0 to 5, because there's 5 years, 50,000 plus 5,000 t, and then you're going dt. That's it. So that's your total value. That's just basically just adding up what you're going to have every year at the end of every year when you do this.
I got 312,500.
Okay, let me try that. Okay, that's correct. The future value is very similar. It's the integral from 0 to 5, 500, 5,000, no, 50,000 plus 5,000 t, and then it's e to the 0.15 minus t dt. It's always that b minus and that rate out in front here. And that's needed to the nearest cent. So you want to give that a try here.
398,721 point. Wait, you said I got 27.
Okay, let me enter that in here. If that is correct, that'll be the end of this homework assignment. And it is correct. I think all of those are done. Yep, full 100%. All right, we're on to homework 13, 14.5. Sorry for not sharing that screen. It's just it's not always practical
Oh,
to
okay.
do that. Okay. Um, Scrolling down. Okay, so you're supposed to decide whether the integral converges. Um, the uh, the how do we want to do this? Have you studied this at all in class?
Um,
It's okay if you
I don't
haven't.
know.
I'm
I think
just
he
I'm
might
just
have
trying.
talked. I think he talked about it last class, but
Okay, so this one we're going to just integrate. There's some notation that you're supposed to do, but I don't want to really deal with that with you because I am. It's not really that important. The antiderivative of x is x squared over 2, and you're evaluating it from 7 to infinity. What I'm about to show you is not the right notation, but it's effective. It's okay. So it's 1/2 infinity squared minus 7 squared. Okay. Um, this infinity squared is yet another infinity. 7 squared is 49. Great. Infinity minus 49 is infinity. 1/2 of infinity is infinity. If you get an answer like infinity or negative infinity, it diverges. So this one diverges, and you type D and E into the field there. Number two, oh, I chose the wrong one. Ooh. The number two does converge, and we're gonna show that here. The notation I'm giving you is completely wrong, but it's more effective for learning to do it this way, because the correct notation is not real helpful for most students. Do you remember the antiderivative of e to the minus x?
e to the x.
It's itself, but then there's a negative out in front because of that negative there,
Okay.
and you're evaluating that from 0 to infinity. So this becomes minus e to the minus infinity minus e to the minus 0. So this is uh, minus e to the minus infinity. So another way to write this is minus 1 over e to the infinity.
Mm-hmm.
E to the infinity is really large, like really large. So minus 1 over a really large number is 0.
But yeah.
Okay. Here, this becomes plus e to the minus 0, which is effectively e to the 0, and e to the 0 is 1. So this thing equals 1,
Mm,
and it does converge.
okay.
All right, we're on to number 3. Okay. Okay, so there is this property that says that if you have an integral from uh, a to infinity 1 over x to the p, as long as p is greater than 1, it converges.
Okay.
And I throw a lot of notation at you, but a is just a number. In this case, p is equal to 1.5. Is 1.5 bigger than 1? Yes, this converges. Now, what does it converge to? That's where it's a little bit tougher here. Um, so you may want to rewrite this integral 1 to infinity as 7x to the minus 1.5,
Mm-hmm.
and then find your antiderivative that way. So it's 7x to the minus 0.5 over minus 0.5, evaluated from 1 to infinity. We can clean this up a little bit. It's minus 14, and then x to the minus 1.5 is 1 over the square root of x. And we're going to evaluate that from 1 to infinity. So this is minus 14 over the square root of infinity minus 14 over the square root of 1. So the square root of infinity is infinity. Minus 14 over a really large number is 0. So that takes care of that. Two negatives make a positive, so 14 over square root of 1, so plus 14. So this equals 14. All right, we're up to 4. this has a bit more. Okay. Gonna snip in number 4 here shortly. All right, this problem, you're integrating e to the x. This thing up here shows that if it's e to the minus x, it does converge. So you might think, oh, it's positive x. Well, it doesn't converge. The problem is it's negative infinity, so it's slightly different than positive infinity. But we're going to do the same thing. The antiderivative of e to the x is itself, and you're going to evaluate that from minus infinity to 3. So we're just going to put this in, so put these numbers in. So e to the 3 minus e to the minus infinity.
Mhm.
Well, e to the third is a number, whatever it is, okay, minus 1 over e to the infinity. E to the infinity is a really large number. 1 over a really large number is 0. This becomes e cubed minus 0, or just e cubed. So this one converges. It converges if it goes to a number, a known value.
Right.
Um, if you take a traditional calculus class, which I don't suppose you ever will, you can actually prove that things converge, but you don't know what they converge to,
Right.
which is a bit odd to think that that's even possible. Um, but nevertheless, that's what you got here. So let me snip the next one in here. Did you ever feel comfortable looking at your grade in this class?
Yeah.
Okay,
Um,
good.
well, so right now I'm at an 86,
Okay.
but he hasn't even included, like, I don't think my homework grade is included in my overall grade right now. And my homework grade is like a 100.
So probably pretty close to an A.
Yeah, but I don't know. It's nervous about the final. So
Yeah.
I don't know.
All right. So e to the minus x, its antiderivative is itself, but because of that negative in front of the x, there's a negative that goes here. This is from minus infinity to minus 1. So we're going to put in the minus 1 first. So it's minus e to the minus minus 1. Lots of negatives. Minus e to the minus minus infinity. So the first one here is minus e to the 1. Second one here is plus e to the infinity. E to the infinity is infinity, just really large. Anything you add to infinity is still infinity. So since it goes to an infinity, it diverges.
Yeah, and I was thinking if it was Zoom, then I could have just like had you log on. Like, you know what I mean? Like, isn't that a thing?
Well, there's still workarounds. I mean, you just how creative do you want to be? And I mean, I can coach you through that, but it's
Risky.
well, no, I mean, not really, but I mean, you can't just hold your phone up and take pictures, but you have to be a little more
Right.
secret than that. I mean, it depends if they're watching your screen or not. And
Maybe they are. Like, I know I have to be recorded.
well, sometimes they're watching your screen, but not you. And then that's another thing altogether.
Oh,
Because what I would, I mean, well, I mean, I know all the things people do, but if I were an instructor, they're usually just worried that you're going out to Wolfram or Mathway or
yeah, but
Picture.
it's like on lockdown to where you
Right.
can't navigate.
Yeah. So then then that takes that variable out. But then are they worried about you? And then they got 30 people to watch. I mean,
Right. Or yeah, that's true.
I don't know. So um, let me just look ahead here, see what else we got here. Um, okay. All right. So this one is quite complicated because it's an integration by parts problem because of this thing in front. So if just a brief review here, u equals 4x minus 6, du equals 4 dx, dv equals e to the minus x dx, and v equals e to the minus e to the minus x. And we're integrating those two. So the uv minus the integral v du is your integration by parts step. The uv is the 4x minus 6 times the minus e to the minus x, and you do have to evaluate that from 0 to infinity, minus the integral v du. So there's a negative here. Well, I'll just write 4 minus e to the minus x dx. So you get that, 0 to infinity. Um, yeah, I'll come back to this part on the left. Part on the right becomes plus integral 0 to infinity 4 e to the minus x dx. The negatives just cancel out. And then you get minus 4e to the minus x, value from 0 to infinity. And then you got all this 4x minus 6 minus e to the minus x, evaluated from 0 to infinity. Okay, so over here you have 4 times infinity minus 6 minus e to the minus infinity minus 4 times 0 minus 6. And then you got whatever that is, minus e to the minus 0. So this e to the minus infinity becomes 0, and it takes all of this with it. So this all goes to 0 because of that. Over here, this e to the 0 is 1. You have a 4, but it's times 0. So you have minus 6 times minus 1, so it becomes positive 6. Is that right? I feel like I got a wrong sign here. Minus 6 times that. Seems like it's minus 6. So this one converges. It just doesn't have a nice value that it converges to. I guess it's minus 6. That doesn't seem right, though. Oh, did I account for that one? I'll just try it. Huh. I don't understand. I must have made a mistake in a sign somewhere here. Let me use a calculator for this. Okay, I don't understand. Oh, minus 2. I can't. Okay, sorry. This all became minus 2, and I don't know why I wrote down the wrong number, but I did. And we can move on to number 7 here. 7 is much more straightforward because, well, no, it's not. There's another thing going on here. I thought it was if the limits are at infinity, you can use the p-test that we talked about earlier. But this time, you're not going to infinity. You might think, well, what's the big deal? Well, the problem is that at 0, this thing is undefined. Um, but that doesn't mean the antiderivative is undefined. So this is 2x to the minus 1/3, but the antiderivative is 2x to the 2/3 over 2/3 here, and that is okay at 0. So sometimes you just have to try it and see if you get something that works here. Um, so this ends up being the antiderivative here. It's 3x to the 2/3 evaluated from 0 to 6. So it becomes 3, and then it's the cube root of 6 squared. I guess that's all they want for this. So it does converge. 3. Try that. Hopefully it'll take. All right, we're up to 8. Okay. So this one is kind of like the last one. There's a problem at 0 because 1 over 0 squared is undefined. You still try and find the antiderivative of those. The antiderivative of this thing is minus 1 over x, and you evaluate that from 0 to 5. It starts out looking okay. It's minus 1/5 minus 1 over 0. Since this is undefined, it's kind of like having an infinity. This in it's sort of in itself is an infinity, but because it's undefined, that means it diverges. So if you can't evaluate the antiderivative at that place, that means that it also diverges.
Uh-huh.
All right, we're up to 9. I guess these are good problems, but there's just not enough of them to help the student. Okay, this one here, if you were to look at the graph of 1 over x to the 1/3, you would see it has an issue at 0. 0 is included in this window, so you actually have to turn this into two problems. Minus 1 to 0, 1 over x to the 1/3, plus 0 to 2, 1 over x to the 1/3. And hopefully it works out. Well, it actually does, because the antiderivative is x to the 2/3, 3/2, and you evaluate that from minus 1 to 0 plus 3/2 x to the 2/3, and you evaluate that from 0 to 2. So you end up getting a value out of this. It doesn't look real nice. So on this side, at the 0, it becomes nothing. So it becomes 0 minus 3/2 minus 1 to the 2/3 power, which it's the cube root of minus 1 squared. So this becomes positive 1. So this becomes minus 3/2, plus over here, 3/2 2 to the 2/3 power. So it's the cube root of this is the cube root of 4, 2 squared, and minus that. So it's, I don't know, it doesn't come out nice, but it does converge. Didn't like that. Oh, 2/3. Put it to the wrong exponent. Jeez, it's not gonna like that. Oh, cube root. What did I put before? Submission 1, 3/2, 2/3. Oh, I keep putting the wrong exponent. Sorry, I'm not putting the right exponent in. That's why it's coming out wrong. All right, last one here. When you said you'd waited too long to contact me, I was thinking, after we've done a couple lessons here, you're probably like, man, I could have got all my homework done in an hour each week.
I know. Well,
And
it's
that's
so
what
true.
people
I
don't.
would always be like struggling on Friday afternoon, like Friday mornings. I'd go to the math tutoring center and like they'd only do like one problem at a time with me and all this stuff. And I'm like,
Yeah, I wish I could sell that to fellow students that you have. Like, yeah, you're gonna pay something for it, but you're gonna have, I don't know how much more extra time you're gonna have.
right, no, exactly.
So,
Because
you know,
the first exam, like I did it no problem, but I got like a 95. But that, and I was like, oh, like my teacher's so great, like I'm learning so well. But I realized it was all review, and then the
yeah, no new stuff.
second exam came around, and then like I was just so unmotivated, and I was like, I just did so bad. And then like that was like 2 weeks later, I was like, okay, I'm gonna contact Matthew.
Well, thanks for contacting me. This last problem, you have another issue at 1 and -1. So you end up having to integrate this thing, because the bottom here, x minus 1, x plus 1, you have issues at both endpoints. So you have to break up the integral to this plus 1 to 3. It's going to be the same antiderivative, so it's you just have to you kind of have to just do this and integrate it and then evaluate it at the bounds. So when you do this u substitution here again, you take the derivative, you set you solve for dx, so dx equals du over 2x, and then you start substituting it back in. So it ends up that your integral looks like 2x over u, and then it's du over 2x. So you end up just getting those canceling out. So it becomes the integral of 1 over u du, which is the natural log absolute value of u, natural log absolute value of x squared minus 1. So what does that mean? Well, you have natural log absolute value of x squared minus 1, and you're evaluating it from -1 to 1, plus natural log absolute value of x squared minus 1 from 1 to 3. So here you get a natural log of 1 squared, which is 1 minus 1. You get the natural log of 0, which is undefined, minus the natural log of 0, which is also undefined. So that's a really bad start. But over here, you end up getting the natural log of 8 minus the natural log of 0, which is also undefined. Since these are undefined, I believe the whole thing diverges. It's again kind of like an infinity. So we'll just test it out here that it diverges. And if it does diverge, in this case it does, you can just type in DNE for what it converges to. So that is it for both of those assignments.
Okay. I'm pretty sure I scheduled with you on Monday, and then
You did.
you
I
have
did.
it said you didn't have anything on like the later half of that week. Are you just booked or
So what I do on my website is I only allow people to book out 1 week plus the
okay.
day. So, but if you need to change that for another day, you can. Like the rescheduling is like as long as you do it within 24 hours or more, it's no big deal.
No, I want to keep Monday. Yeah.
Okay.
Oh,
Um, if you need another time, just text me. Say I really need a 2 o'clock and whatever. But
okay.
like today, you'll see stuff for next week. And if you need something on a Friday, I will be available. It's outside of my normal scheduling.
Okay. I'll probably schedule for Thursday, like since it's the night before my final.
Okay.
And so that Monday and Thursday are both review because I remember looking at it, but he gave a review and that I want to see how many questions there are because it might be like literally the test but different numbers and like that would just be a good tool. Um,
So this class, I've seen 2 different versions of this semester. One, all the exams are in WebAssign. The other version is the instructor has questions that you fill out, multiple choice, then you upload 3 or 4 questions to Canvas. Not
no,
this instructor though. I don't know which instructor it's
this
for.
one's on WebAssign. It's gonna be exactly like the test that we did
Okay.
like
And it's
last.
just going to be these WebAssign questions. Like here, you'll probably get like a 3 would be one I would think you'll get. Um, not 6, probably 7. You'll get one that diverges, maybe a 9.
Right.
You'll definitely get one of those, producer consumer surplus questions or more.
I'm pretty sure I don't think it's cumulative. I think it's just on the last few like chapters that we've been doing. So that's not too bad.
All right. Well, I guess we can stop here. I'll send you the notes and the screen recording here shortly. Thanks so much for
Okay.
scheduling, and I'll see you on Monday.
Yeah, thank you.
You're welcome. Bye now.
Happy Thanksgiving.
You too. Bye.